Welcome, everyone. Here we are to Data 8, Friday before a long 3-day weekend. So some announcements for today. The instructor office hours. We love seeing and talking to you. My office hours will be Tuesdays, 11 a.m. to noon, starting next Tuesday in Bechtel Terrace East. That's outdoors at the picnic tables in Bechtel Terrace.
Hey, David, can I just add that these informal office hours of mine, I'll formalize them with something very similar to David's by the end of today.
Great. Also, signups for tutoring sections are out. We invite you to sign up for tutoring sections. They're weekly, 1 hour a week, meet with 4 or 5 students and a member of course staff to guide you through some practice problems. Your lab 1 scores will be released later today, and regrades will be due by next Wednesday. And homework 2 will be released later today, and that'll be due next Thursday. I hope homework 1 went well. As usual, you get bonus 5 points if you submit a day early of the homework. So if you submit by next Wednesday. Next Wednesday, 9/8. Sorry about that. In fact, why don't we fix that now? All right, we're not going to fix it now. Should be, sorry about the typo, that should be next Wednesday, 9/8. All right, so I've been showing you coding in Python and organizing your data with tables. And today what I want to show you is arrays and using that to work with data stored as a table. All right, so let's start with a demo of working with arrays. I don't have online office hours, but we do have course staff online office hours in the evenings every week.
I might have some online office hours in the evenings for people who are in very different time zones.
Closed captioning. Okay, let me see if I can figure out how to turn that on. Maybe Professor Nee, you could check if you can see how to turn that on, because I am not seeing it.
Actually, I looked for it and I wasn't seeing it either. This is most unfortunate.
I think we're going to have to try to figure out how to do this because I am not seeing how to do it. I apologize. I'm going to carry on. We'll have to look this up after lecture.
Somebody
all right.
says, yeah. Somebody says internet at Doe is really bad. Evans is fine. Maybe walk outside. Sorry.
Yeah, sorry about that. All right, so I'm going to show you a demo with arrays here. And an array, as I mentioned on Wednesday, is a sequence of values. In this case, we're going to make an array with a sequence of numbers. So here the numbers are 1, 2, 3, 4. And we can display the array we just made well, we did an assignment statement. What did we do here? We called a function called makeArray. That function creates a new array. It creates an array with the contents 1, 2, 3, 4. This is an assignment statement, so we associated that with the name myArray. we can then enter my array into a cell, and that will display the contents of the array. I see that some of you are trying to raise your hand, and I apologize, but I'm going to continue on with lecture and take questions in the Q&A. The video feed is lagging. Okay, I can try to fix that. I will try this one more time. Let's try it another way. All right, how is the video feed now? Is this any better? All right, so we created this array. We can view the contents of the array. The function makeArray is one that we provided for you that creates an array. Now, if you have an array, you can, one thing you can do is you can look at the length of the array. Oh, you're seeing the chat box now, huh? All right, let's close the chat box so you don't see the chat box. The length of this array is 4. There are 4 numbers in this array. Another thing you can do with an array, another function that's provided to you, is the sum function. What the sum function does is it adds up everything in the array. So let's take a look at that. In this case, the sum of everything in the array is 1 plus 2 plus 3 plus 4. That's 10. So it's showing us here 10. This is blurry. Oh, no. Okay, so before was better?
Yeah, I can't read the chat either.
Very good. We'll do it the way we did it before. Sorry for all these problems, everyone.
This works now.
All right. Now are we better? No blurry? Better. Okay. Do you see a chat window that is blocking your view? Great. Okay, good. Everything is the way we want it then. So sorry about the video lag then. I guess we'll just have to put up with it. All right, so we've shown here we can take an array, we can find the length of the array, we can sum all the numbers in the array. And if you wanted to get the average of the numbers in the array, one way to do that is to take the sum and divide it by the length. I'm hoping that what you'll see on the left side of the screen is a picture of me in real time. I don't know if you can see me over there, but that's what you should be seeing. Great. There is another way to compute the average of an array. And that is to use a function that has been provided for you. And that function is called np.average. And so if we run that function on our array, it will compute the average of everything in the array. So that's just another way to get the average. You could use either one, whichever you like. Let's create another array. What does len do? Len is a function that accepts an array as a parameter and returns the number of items in the array. In this case, the array had 4 numbers in it. So the len of this array is 4. It returns the length of the array. NP, you don't need to worry about this too much, but there is a built-in library that's provided with Python called NumPy. And that provides ability to do some kind of computations, especially with arrays. All right, so let's make another array here. We're going to make a second array. let me display for you this array. So here's the second array, has a different set of numbers in there. One thing you can do with arrays is you can add them. This is kind of weird and kind of nifty. We know how to add numbers, but if you want to add two arrays, what Python will do is it will add the first number in the first array and the first number in the second array. So it adds the 1 and it adds the 70 to get 71. And then the second number in each array adds them up to get 62. And the third number in each array adds them up to get 93, and adds the fourth number in each array. So here we're doing something on every item of the array. Now, let me give you a little bit of warning about this adding stuff. If you try to add two arrays like this, you'll get an error message. So why did I get an error message here? If I look at the error message, it says something totally obscure. I don't know what the heck that means. Well, I do, but at this point in this class, there's no reason you would know what that means. What's going on here is that Python is trying to add up the two arrays, line them up, and add the first numbers in each, the second numbers in each, but they're not the same length. So when it gets to adding the fourth number in each, wait, there is no fourth number in this array. It can't do it. So Python bails out and gives you an error and says, sorry, no go. All right, so we tried to add an array of length 4 and an array of length 3, and that doesn't work. If you want to do this adding thing on arrays, both arrays have to be the same length. Now, arrays can have not just numbers, they can also have strings in them. So here is an array with 3 items. Each item is some text. You can try to do some operations on this, but Python doesn't like that. Lastly, I want to show you how to get back data out of an array once it's in an array. There is an operation on arrays called item. So what I've typed here is I did an operation. The operation, like the name of the function or the name of the operation, is item. The name that it's working on, the thing that it's working on, is it's working on an array named tunas. And the argument here indicates which item I want to get out of the array. So if I want the first one in the array, then I pass 0 to item, and this will give me the first one in the array, bluefin. Now, super confusing point here. In Python, when you want the first item of array, you don't ask for item 1, you ask for item 0. Python starts counting with 0. It doesn't start counting with 1. If you asked it to count, it wouldn't start counting 1, 2, 3. It would start counting 0, 1, 2. So we have to mentally translate, I want the first item, but in Python, that's going to be item number 0. We sometimes call that the item at index 0. Okay. So these indexes, the indication where they are going to be one lower than, we'd be thinking in our brain. All right, so we could now get item 2 from this array, and that's not the second item, that's the third item, right? Because we start from 0. So the item 2 is 0, 1, 2 is Jim. Finally, if you ask for item 3, there is no 3. That would be the fourth item, but there is no fourth item. There's only 3 items. So 0, 1, 2, oh, wait, there's no item whose index is 3. So you get an error message, and the error message says it's out of bounds. Index 3, we asked for index 3, is out of bounds. It's past the end. There's no item with index 3. Okay, yeah, so there's lots of stuff you'll see on the screen, and you don't necessarily need to understand all these error messages. So this is arrays.
Professor David.
Yes.
One thing I think we should do once and for all, because there's 100 questions about the same thing, which is an array the same as the list? It's been answered, but it may be worth saying.
Array is not the same as a list, and we have not introduced lists yet, but we will. When we get to lists, we'll talk about the difference. For those of you who know what a list is, the short version is all the items in an array have to have the same type. But for a list, they could be a variety of different types. You could have a list with numbers and strings, but an array has to be all numbers or all strings. And if you don't know what a list is, don't worry. You don't need to know it right now. That was just for those who happen to already know what one is. All right, so that's arrays. Array is a sequence of values. All the elements of the array should have the same type. When you do arithmetic like addition, it's applied to each element individually. If you add two arrays, then it adds, kind of lines them up and adds one at a time, the items. And here's a key point that we're going to see in a moment. When you have a table, the column, each column of the array, each column of the table is an array, because in a column, in a table, they're all the same type. Like one column might be the population of a state. Those are all numbers. So that forms an array. Now, there's a particular kind of a way of creating arrays that's we'll use a lot, called a range. So let me show you how to work with range. Here, I could make an array that has the numbers 0, 1, 2, 3, 4, 5, 6. Kind of a pain to type that in, because I would have to type all those in. And if I wanted an array that has the numbers from 0 to 1,000 to be really a pain, I'd be typing all day. So anytime you find yourself typing all day doing something tedious, instead look for a way to get the computer to do it for you. And we have a built-in function that we provide to you that gets the computer to do that for you. And it's called np.arange. Arange stands for, in my mind, the way I think of that is array range. So this is a function. The name of the function is np.arange. And the argument here that we passed is 7. And what this does is it creates a range of numbers up to 7, but not including 7. Remember that Python counts starting from 0. So it's going to count up to 7, but stop before it gets to 7. So it's going to be 0, 1, 2, 3, 4, 5, 6. You can also specify a range if you don't want to start at 0. You can indicate where you want it to start at. So if you pass 2 arguments, the first argument is where you start at, and the second is stop before you get to that one. All right. So np.arange on 511 starts counting at 5 and stops before you get to 11. 5, 6, 7, 8, 9, 10, and then stops. So it includes the starting point, but it doesn't include this ending value. One more thing you can do is if you want ranges that count not by 1 at a time, but go up by 2 or 3 at a time, you can pass a third argument that says how much should you go up at each time. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. All right. You see what happens here is we started at 0, stop just before you get to 20, go up by 2. Now, if I said stop just before you get to 21, then it would have included 20 because it gets to 20. It hasn't been 21 yet, and then it stops. You can count up by increments of smaller than 1 by an increment of 0.1, for instance. And you see here you get the fractions 0, 1/10, 2/10, 3/10, and so on. All right, so this is handy if you want to create a range. One more thing I want to show you is I want to show you to illustrate this point I made earlier about the relationship between tables and arrays. So let's look at a table here. I'm going to load in this spreadsheet of NBA player salaries and pull out just the salaries for the Warriors. So here were the salaries of the members of the Warriors in 2015. And you can see there's Draymond and there's Steph Curry and so on. Steph Curry was making $11.3 million in 2015. So the salary column here is a bunch of numbers that is stored as an array. You can look at just that column if you want. This is a table that has just one column, or you can extract that as an array. So there's an operation on tables you can do called the column operation. And you tell it which column you're referring to, the label of one column, and it will give you all the values in that column as an array. So here we can see an array that has 15.501 and then 14.26, each of these values, but now there is an array. And that's useful because if we want to do operations on the data, we can use the array operations. We can extract an array for a column and then do array operations on that. Like for instance, if I wanted to know what the average salary averaged over the members of the Warriors was, I could extract this array and then use np.average to compute the average of those numbers. All right, so the average salary for an average member of the team, 6.72. Now we could pull out from this spreadsheet data about just the Toronto Raptors. And then maybe if we wanted to know about how the average salary on the Warriors compares to the average salary on the Raptors, we could do this expression here. So the first part of this expression computes the average salary of all the Warriors team members. The second part computes the average salary of the Raptors team members. And then we subtract those two averages. And the answer here is 2.3. So that's 2.3 millions. And what does that tell me? Does that tell me the average salary on the Warriors is higher or lower? All right, higher, yeah. So the Warriors, if you're gonna join a team, maybe that's an indication that maybe the Warriors are paying better, or maybe they had more budget so they could hire more expensive players. All right, so this shows how you can get data out of a table into an array and use that to do various operations. All right, so we talked about ranges. Ranges is just an array. It's an array of numbers, and it lets you count up. You can specify just the end point, and it will count starting at 0. You can specify the starting point and an end point. It'll count starting at the starting point. The ranges never include the end value. You can also specify how much to increment by. So let me check any questions on ranges, arrays, or how to get arrays out of a table. Do we have another way to take the value from a table? No, at least not yet. The usual way to get a value out of a table is to get an array out of it. And if you wanted just one number, not the entire array, suppose you wanted the first number in the salary column. Does anyone have any ideas how we could get that? Yeah, dot item. Use dot column to get the array of salary values. And then on that array, use dot item 0. And that will get the first item in that array. Very good. So you can combine these operations. Good job. What happens if you put a negative value for step? Oh, I love these kind of questions. These are my favorite kind of questions because there's something I want to get you comfortable with. I want to get you comfortable with trying this stuff on your own. So you can go to the demos notebook on the site, and you can create a cell, go to insert cell below, and try it. Type some code in. You're not going to cause any problems. You're not going to harm anyone else. You got your own private version. So let's just see what happens. Suppose that I type np.arange 0, 10, and then I'm going to put -3, and I want to see what happens. I don't know what happens, but I'm going to try it and we'll see. Oh, I didn't like that. Well, that's maybe not a surprise. Counting up from 0 by -3, you can't really get to 10 that way, can you? Oh yeah, what if I start at 10, end at 0, and count by -3? Oh, that's worth a try. Let's see what happens. Oh, that was interesting. It started at 10, and then it went down to 7, and then down to 4, and then down to 1, and then it didn't go down any further because it would have gone below 0. It would have gone past the ending point. All right, so yes, you can put a negative value there. Now, it's not that I feel it's really essential for you to know that negative value, you can use negative values with ranges. What I think is essential for you to know is when you have questions like this, is that I want you to feel comfortable trying it out in a notebook and experimenting and seeing what it does. Often you can figure out a lot by trying it. Are the steps only addition or subtraction? Yes. What if you wanted an array of a geometric series? Ooh. Well, I think we might have a lab exercise on that. Suppose you wanted the numbers 1, 2, 4, 8, 16, 32, 64. Well, I'll give you a hint. Here's what these arrays look like, what that sequence looks like. I could type in an array like this, and this gives me a sequence that's going up by a factor of 2 each time. See what I did here? I did this exponentiation. I said 2 to the first power, 2 to the second power, 2 to the third power. And you notice how it took me a while to type that. That got kind of tedious. Well, if I don't want to type that, or if I want to have a really long array, there is a clever way to do this. Don't spoil it. Okay, I won't spoil it. When you find yourself trying to do the same thing over and over again, ask the computer to do it. And maybe I'll give you a little hint and then I'll leave it to you to discover it. Notice how this is kind of going 1, 2, 3, 4, 5, 6, 7, 8, 9. I bet we know how to make a range like that. A range 1, 2, 3, 4, 5, 6, 7, 8, 9. Could you do anything from there to get to where you want? All right, that's enough of that. So now I want to move on to next subject. I want to talk about how to create a table. There are 2 ways to create a table that we're giving you. One way you've already seen is if you have a spreadsheet that's formatted in CSV format, then you can read it in using this function that we provide called table.readTable. And then the argument is a file name. So you have to upload your spreadsheet into the same directory where the notebook is, and then you can read the table in this way. The other way is that we give you a way you could create an empty table. And we'll see how you could start from an empty table and add stuff to the table. And finally, if you have an existing table, you can create new tables based off of it using operations you've already seen. So let's go through some examples here. One way to create a table would be to start with an array. So here I've made an array of street names that are just south of campus. I can create an empty table using this code. This is basically, there's a function that's called capital T table, and you pass it no arguments, and you get back an empty table. You can see there's nothing there. It has no rows and no columns. That was a kind of a useless looking table, but it's a build, it's a start. It's something we can build on. So tables have an operation called with column. And the with column operation takes an existing table and adds another column to it. Remember that columns are arrays. To add a column to a table, what we're going to need is we're going to need a label for that new column. And we're going to need the data that goes in that new column. So the label is just a string, it's just text. And then the data is an array. So this operation with column needs 2 arguments. The first argument is the label of the new column to add, and the second is the array of the data to go in there. And we're going to start with an empty table and add 1 column to it. The 1 column we're going to add is with the data taken from this array that I just created. So let's look at what happened if we do that. Now we have not an empty table, but we have a table with 1 column. The label is streets, because I specified that as the first argument. And the data is taken from this array up here: Bancroft, Durant, Channing, Haste. So you can, if you have a table, you can get an array out. If you have an array, you can get a table from that. Now, maybe I want to add more to this table. So here's another thing I could do. I could add a second column. The second column will have the label blocks from campus. And that'll have the number 0, 1, 2, 3, 4. So this with column, I need to pass 2 arguments. The first is the label of the new column. I did that. And then the second is an array for the data. Now, I could have created an array with the data 0, 1, 2, 3, but a way that saved me a teeny bit of typing was to instead create a range. Use np.arange to create a range, create an array that has the numbers 0, 1, 2, 3. All right. So that was just a little trick. So now I've got a new table that has 2 columns. Let me display it. Oh, wait. What happened? Where did my second column go? We didn't assign it. Yeah, I didn't save it. Yeah. This dot with column operation, it doesn't modify the table it's operating on. Instead, it creates a new table that has all the data of Southside plus some more. So it created a new table and we displayed it, but then we didn't do anything to save it. And Southside was unchanged. So it had only 1 column and it still has only 1 column. So this new table we created, if we want to then do something with it, we're going to need to save it. And the way you save it in Python is with an assignment statement that associates it with a name. All right. So what I should have done was I should have assigned it to a name. And what I'm going to do is I'm going to reassign the name Southside to now be associated with this new table with 2 columns. All right. So there I use an assignment statement to save the result of this new table. And we can now see that the name Southside is associated with this new table with 2 columns. Now, if you want to add multiple columns, instead of using with column, you can use the operation called with columns, plural. And that will let you specify as many additional columns as you want. For each column, you have to specify the label of that column and then an array that contains the data for that column. You can use any expression you want for this array. It could be the name that is associated with an array. It could be some expression that results in an array. So here's an alternate way I could have gotten that table. I could start with an empty table. So this creates an empty table, starts with an empty table, and then I'm going to do an operation on that empty table. I'm going to do the with columns operation on it to add, in this case, 2 columns. And here is the result. All right, so this started with an empty table, added 2 columns. The first column label was streets, and the data was taken from this array with the name lowercase streets. And the second column is labeled blocks from campus. And the data is taken from this array that was generated here with the np.arange expression. The lengths of these columns, that's right, have to match. Otherwise, you'll get an error. Does the indentation matter? No, not really. So let me show you an example. I could have written it like this. I could have put it all in one line. All right. I could have put it all in one line. Also valid. The same thing. But I didn't want to do that because it got so long you couldn't even see it. And plus it's a little messy to read. And so I added some spacing in here to make it a little easier to understand what's going on. Now, if you do have indentation, then I think that probably each subsequent indentation needs to be the same amount of indentation. Why did I repeat streets twice? Oh, it looks like I did, but actually these are 2 separate things. See this thing here in red? That is a string. See those quotes around it? So that's text. As far as Python is concerned, that's text, and it's not going to interpret that or do anything with it. It's just a string that's going to copy over verbatim. The second thing happens to have the same word streets, but from Python's perspective, it's totally different. It's completely unrelated. This doesn't have quotes. So this is not a string. This is a name. And I assigned to that name earlier. I assigned to that name way up here. So when Python sees the second streets, it knows it's a name and it tries to check for what do I have associated with the name lowercase streets. All right, so maybe it would have been clearer if I had used a different name for that variable. So here's a different way I could have done it that might help you understand a little better what was going on here. I could have instead called this array st names. And then I could have created the table like this. And here I'm referring to the data in the array with the name st names. So you can see that it's not actually the same thing here. This is text that's not interpreted by Python, and this is code. This is a name. Why did I use np.arange for? I didn't have to. That was me getting like clever. So I could have done this. That would have been worked. But you notice how np.arange for was just a little bit less typing. So that's why I used np.arange. And the other reason is if I had 1,000 streets, I wouldn't want to type 0, 1, 2, 3, 4, 5, 6, 7, 8 up to 1,000. But it's easy to type np.arange 1,000. A lot less typing if this was a bigger table. So that's an idiom you'll sometimes see later in this class. And so I wanted to expose you to it. All right, so now I want to do another example. I want to do this time a case study. And I want to do a case study. This is from W.B. Du Bois, who was an activist and arguably one of the earliest data scientists. You can see he lived in the late 1800s and early 1900s. Yeah, amazing dude who did just so much. And fascinating life. And from what I've read about him, yeah, he was a sociologist. He wanted to understand people, and he studied Black people in the U.S. And so at the time, it was extremely racist society, and he went around to understand what the lives of Black people were like. And then he wanted to, he was also an activist. So interesting, we often see these go together in data science, where you have a combination of the scientist who wants to understand the world and the activist who wants to change the world and who uses the science to support change by showing people the way the world is. And then, you know, kind of maybe often the point is, hey, this is broken, this ain't right. Did you know? All right, so he did a bunch of science and data analysis, and he did a bunch of advocacy, and one of his themes or missions was trying to change the way people perceived Black Americans. And he did that by gathering data on what the lives and situations were like of people, and showing the results of that data. And I want to show you one chart. One of the things he did was he went to this this expo, this international expo, to give a presentation to raise awareness. And he prepared, in the space of 3 months, 60 charts by hand, which today, with all the software tools we have, would be no big deal. You could make 60 charts in a day. But he did this painstakingly by hand. So that was a big deal. And these were beautiful, beautiful visualizations. So let me show you one of them. I want to take a look at one of these. And I want you to just take a couple of minutes and look at this and see what you can spot from this visualization. Does anything jump out at you? Is there anything this is telling us? What is this showing us? I know, it's so clean. Can you believe this is handwriting?
Guys, please be aware that this is a photograph of a visualization, and the text at the top uses language that was in common use in those days, but we do not use it anymore. So please be really careful when we use historical data and historical visualizations, historical text. We always have to be conscious of this.
It's very organized, yes. It uses coloring to help you understand the data. This is actually his handwriting, yes. What do the colors represent? Spending. Yeah, spending in each of these categories. The categories above, the black numbers represent spending for rent. The purple is spending for food. Yes. What do the rows represent? Income. Yeah, income levels. It calls this class. Economic class. Yeah, so you can see how the proportion of what household spending was like for families at different income levels, and shows just what the differences are, and maybe gives you a little bit of a feeling for what their some aspects of what their lives might have been at some very, very basic level. For instance, we could see big differences in discretionary funding, funding for things like entertainment and so on. You can see big differences for rent. Why do you think that there's no black, this kind of 0% spent on rent, none of this this dark black category for the bottom two rows? What does that indicate? Yeah, the richer folks are able to buy a home, and so they aren't spending money on rent. Okay, so this is data that was painstakingly compiled and presented by hand. I wanted to show you how we could do some kinds of analysis with this data set using the Python environment that we've seen here. All right, so we've got this data in a spreadsheet, and we can load this into a Python notebook. So here is the same data, just presented in a way that's not nearly as pretty or easy to understand. This is the underlying data without the visualization. And you can see these different columns. For instance, the column class is the range of incomes, families in this range of incomes. And you can see, for instance, the rent column is the percentage of the household income that's spent on rent. And actual average is the average income of households in that category. All right. And he labeled the different ranges of incomes of status. He gave some label to what he was calling their socioeconomic status, like the comfortable or the well-to-do or the poor. All right, so let's take this, and you can see this data shows the income, and it shows the percentage spent on rent, percentage spent on food. Suppose we wanted to look not at percentage spent on food, but we wanted to understand the amount spent on food in dollars, not in percents. So let's look at how we could get that from this data. Well, the first thing we could do is that we could get out an array here. Any of these columns, we can get an array that has the data in that column. So here is an array with the data in the actual average column. And I can do this for each column. Maybe I should give you a sense of where I'm going. I wanted to get the actual amount spent on food in dollars for each of these categories, for each of these rows. Now, if I had a calculator and I wanted to do it by hand, I could do that for each category one at a time. The amount spent on food each month would be the income, 139.1, times the percentage of their income spent on food, so times 0.043. So if I multiplied 139.1 times 0.043, that would tell me how much was spent on food each month by families in this category. And then I could go down to the second row and I could multiply 249.45 times 0.47, and that would tell me the amount spent on food by families in the second category, and so on, and do that for every row. And then I will get the amount spent on food for each of these categories. But that's a little tedious because I'm doing the same operation for each row. I'm multiplying two numbers for each row, and I'm doing that, multiple times, once for each row. Anytime you find yourself doing the same thing many times, you might want to think array. If you wanted to do the same thing on every element of an array, then arrays make it easy to do that. All right, so what we're going to do is we're going to get this data into an array, these numbers here with the actual average income into one array. We're going to get the percentages spent on food into another array. And then we're going to do an array operation on these two arrays. And what I want to do is multiply, but element-wise, multiply the first elements, multiply the second elements, multiply the third elements. And so what I can do is I can multiply the arrays. If I ask Python to multiply the arrays, it's going to do that one at a time. So what I get here is a new array where 59.813 it got by multiplying 139 times 0.043. And this 117 it got by multiplying 249 times 0.043. All right, so you see that this typing, I typed once, do the multiplication operation, and did it on everything in the array. Now, in this case, doing it one by hand wouldn't be so bad because there's only 8 rows. But sometimes you'll deal with a table that has 8,000 rows, and you don't want to do it one by hand with 8,000 of them. But here you can see if you work with arrays, it's 3 lines, no matter how many rows the table has. Now, you can see here the amount that each class spent on food each month on average. But it's a little annoying that if I want to look up for class, the category of people whose income was average monthly, whose monthly income was between $400 to $500, I have to figure that out. I can't read it from this table. I have to say, well, that was the 4th row in the table, so let me go look at the 4th number in this array. And oh, that was $160 a month spent on food on average for those households. That's a little annoying that they don't line up. So what we can now do is we can get it lined up by adding this to the table. So how would I add this array to the table so everything lines up? Yeah, it's kind of like I want to append it. I want to append it not at the bottom, but on the right. Yeah. Yeah, I want to add a column. And we talked about how to add a column to an array. We use with column. The with column operation lets me add a column, and that's exactly what I want here. I'm going to need an array of the data to add, but oh, wait, I've got an array of the data to add. I've got exactly what I need. All right, so let's take this new array and let's save it. Let's associate it with a name. So I'm going to give it the name food_dollars. That will be a name that is now associated with this array here. And then I'm going to add a column using the with columns operation. Start from this table up here and add a column to it. And the data is going to be the data stored in this array that I just computed. All right. So when I do that, I get this new array this new table that looks like this. It's the original table, all this data from the original table, but one more column tacked on at the right. I called that food dollars, and that contains this data here. This is the average amount in dollars spent on food each month for families in that category. All right. It always goes to the end when you use with column. It always adds at the right end of the table. What if I wanted this not in the right-hand side? Yeah, that would be nice, wouldn't it? All right, let's do that. Let's add it, but not on the right-hand side. So what we're going to do now, a way you could do that is you could do the select operation and specify the column names in the order you want them. Okay. So let's maybe we're going to get only food dollar and taxes. Let's run that. Oh no, it didn't give me what I wanted. I wanted a table with 4 columns. These 4 columns in this order, but I got an error. So I guess when we get an error, we go down to the bottom and we start reading from the bottom, and it says value error. The column food dollar is not in the table. The table contains these columns, and food dollar is not one of the columns. So what went wrong here? I can see food dollar up here. Oh, I created this new table, but I didn't save it. Remember, with columns doesn't modify the existing table, it creates a new one. So what I need to do is, I see, okay. What I should be doing is, I could do this. Associate it with a name. And then now I save that table and I do the select statement and everything is okay. And so this select allows me to pick which columns I want, but also the order that I want. So you can see here, put them in the order that I listed. So if I wanted all of the